Okay. And let's begin. Hey, everybody. Welcome back to the second session of our Nolly Dataway special presentation in our Lakehouse catalog crash course. In the previous episode, we talked about sort of what is a catalog and just the whole concept of a data lakehouse catalog, the Iceberg REST catalog specification, things like that. Now, in this episode, we're going to start going deep into very particular catalogs. In this case, Nessie and Polaris. And then I'll cover other catalogs like Unity, Lakekeeper, Gravitino, AWS Glue, etc. in December 10th in our next episode. But the idea is just kind of giving you this nice appreciation for sort of the different options that are out there and sort of what each one brings to the table and the level of innovation that's kind of going on in this space currently. But of course, we always like to, one of the things, the key pieces of having needing a lakehouse catalog is having a data lakehouse with a table format like Apache Iceberg. So if you want to learn more about Apache Iceberg and you don't already have a copy of Apache Iceberg, the definitive guide, do scan this QR code so that way you can download a free copy of Apache Iceberg, the definitive guide. Also, Gnarly Dataways, again, is part of our, we do a regular podcast, a broadcast of Gnarly Dataways, which you can subscribe to on YouTube, Spotify, and iTunes by basically looking up Gnarly Dataways. Now, let's begin with our featured presentation. We're going to be talking about first Project Nessie, and then we'll be talking about Apache Polaris. But both of these are both lakehouse catalogs, meaning they are used to help track your Iceberg tables. So that way you can interface with those tables across many tools in the same way that you would interact with a catalog of tables in a database or a data warehouse by just being able to run SQL queries against them, being able to refer to them by their table name, and just do operations on them. Now, Nessie is particularly special because it basically introduces this whole idea of data as code or data ops, specifically when it comes to trying to bring Git-like functionality to data lakehouse catalogs. So data lakehouse tables inherently already track versioning of the table itself, okay? Meaning basically whether you're talking about Delta, Hoodie, Iceberg, they all have snapshots of the table and you can time travel to previous snapshots, roll back to previous snapshots, but that's pretty much it. It doesn't necessarily contain lots of the things that working with Git does, and being able to have sort of branching histories of your code. So that way you can isolate work on your code, being able to tag certain commits so that way you can easily replicate certain points in time. Eventually that did get introduced at the table level in Iceberg, but that was after the development of Nessie, which introduced this sort of concept at the catalog level. So let's just kind of reemphasize that. So the idea is that when we're talking about Git and these Git-like semantics, what we do is the idea is that every snapshot is a commit. So basically you're taking your snapshots of changes. In this case, with Git is code. But sometimes I want to make changes to the code. So maybe I want to add a chat feature to an app that I'm developing. I don't necessarily want to write that into what's referred to generally as my main or master branch, because that is my production branch, and I don't want my production application users seeing these changes I'm making them before they're complete and tested. So what I can do is I can make a branch, and then in this different use case, there's also a tag where I can actually say, hey, you know what? There's certain commits that I want to refer to on a regular basis, and I can give them a name so I can easily refer to them by a particular name, and that's a tag. But again, to create that chat feature, what I can do is I can create a branch, do work on that branch, creating several different commits, making changes to that branch that doesn't affect production. So in this case, if we're thinking of something like Facebook.com, your average Facebook user, they're experiencing the version of Facebook that's on the main branch. So they're only seeing it as of commit 3, while I might be adding some sort of new feature to Facebook, and I can see all the changes I've made because I'm operating from my branch. Okay, and this allows me to isolate that work, and then once I feel like it's tested, it's been gone through code review and all these good things, it can then be merged back, and now that commit becomes the head of the history over there on the main branch, becoming what everybody else sees. So this allows us to collaborate better, allows us to validate our work better, and overall just build a better environment for managing changes to our code. So why not apply that same concept to data? Okay, being able to better manage changes to our data. Okay, and again, part of that is isolation, being able to isolate the work. So that way the work that's being done doesn't affect the people who are using the already validated stuff, your main production branch. Being able to create 0 copies. Okay, so going back to that Facebook example, if I create a branch, I'm not duplicating all the files that all the code has. All I'm doing is each commit doesn't have the files. What they do is they contain the changes to the files. So basically, I'm only incrementally increasing storage, not duplicating my storage to create this sort of isolated environment, which is really useful when you think about it for data, because how oftentimes do we want to have a development environment that involves us creating a complete copy of our data? That increases our storage costs, takes time to build, and sometimes doesn't always match production. So then when you run your tests, doesn't you miss certain things because you're not working with an exact copy of your production data, because your production data is changing in parallel. So being able to kind of create this 0 copy that can remain consistent with your production data, that'd be pretty nice. Okay, multi-table because with the way Nessie tracks versioning, it tracks it at the catalog level, and the catalog tracks all the tables. Essentially, you're now capturing not a single table snapshot, but multi-table snapshots, which enables multi-table semantics, multi-table transactions, multi-table rollbacks, multi-table tagging, multi-table isolation, which again makes life a lot easier, especially when you're dealing with hundreds, if not thousands, of tables. As I mentioned, rollbacks and reproducibility. If I can tag a particular commit, this could be really useful with data, so that way I can make sure that, hey, I might want to make an end of the month tag, so that way I have a consistent definition of what the end of the month is. Okay, instead of people using different timestamps to run time travel queries, we can have a consistent timestamp that says this is the end of the month. So when you want to run queries against the end of last month's data, this is the tag you refer to, keeping things reproducible but consistent in that reproducibility. And be able to, again, that isolation allows us to validate our data, allows us to test our data in a space before we actually publish it to production. And again, using tools like Airflow and dbt, we can then automate a lot of this validation and then basically create CI/CD pipelines, where basically we add the data in an isolated space, we validate it using typical validations, and then automate that merging based on successful validations. So the kind of way to imagine how Nessie works is that usually your typical Iceberg catalog just contains a list of, hey, this is table A, and this is like the metadata for the current snapshot for table A. Really, what's the current metadata.json? But to keep it simple for today, I'm going to use a number to represent sort of like the version of the metadata.json. So in this case, usually there's just a single list, and that list mutates in a catalog. So it changes, and there's no historical record of those changes made to those mappings. Okay, so once table A moves to version 2, there's no record of when that change happened and what was it referring to before, none of that. This is where Nessie is different. In this case, every time it takes this list of tables to their metadata locations, it actually treats it like a snapshot. So in this case, the initial commit is a listing of tables to their relative snapshot, and then any additional commit would track a change. Okay, but I can now, because we have these commits at the catalog level, I can see what the list of tables was before and after the changes, because those historical versions of the table listings are kept. So I can see here that table B was updated, and it's pointing to version 2 metadata.json. Okay, so this now allows me to sit there and say, hey, I want to create a branch. Okay, and the cool thing is this would be the main branch. So now all my production queries would only be querying the catalog based on the snapshots being pointed to in commit number 2. While I'm making changes to multiple tables here, so you can see I updated table A, then I updated table B again. And now all those changes on the branch are not being seen by the queries that are coming in. Because, again, that part of the history of or the evolution of the table is being isolated on a separate branch. And again, that's across multiple tables, because again, now Iceberg does have this natively for a single table. The benefit here is you're doing it across multiple tables, so I don't have to be continuously making a branch for each table. I just make a branch for the catalog, and then I can work on the catalog in isolation. And then once that is done, okay, I can then just merge those changes in there. Okay, and that provides a lot of, again, possible benefits. Okay, as I mentioned before. And again, I can tag particular commits as well and say, hey, here's my end of month commit. So this is the catalog as it was at the end of the month. So instead of me having to tag each individual table, I can just tag the whole catalog, and now everyone can reproduce every table as it was at that particular moment in time. So now when we get to the specific benefits of Nessie, so we talked about the benefits of versioning, because again, catalog level versioning is the only level of versioning available to the Lakehouse. I have another presentation that I've done at several conferences where I talk about different types of versioning. There's like file level versioning using tools like LakeFS. There is table level versioning that Iceberg has. You can do branching and tagging at the table level built into the metadata. So the benefits, one of the unique benefits of Nessie is that it's catalog level. So you're operating across multiple tables, okay, within sort of that table level, that table abstraction, meaning it enables SQL. It's open source, okay, so you can use it, you can contribute to it, it exists, it's open source, you can see the code, you know what you're working with, and you can deploy it for free, you can self-manage it, or you can use like a managed version like Dremio Cloud's Cloud Catalog, which is Nessie based. It's cloud agnostic, meaning you can use it with any cloud. You can use it with Azure, you can use it with AWS, you can use it on-prem, you can use it wherever you want. Okay, it's storage agnostic. So going back with that on-prem statement, you could use it with Hadoop, you could use it with object storage, you can use it anywhere you'd like. And it comes with its own optimization tools, because one of the challenges of this adding this paradigm in there is that basically the way you would have to optimize it, it makes the whole determining sort of which snapshots you can clean up a little bit trickier. So there is a tool called the GC Cleaner created as part of the Nessie project to help address that problem. So that way you can clean up your tables across your branches just fine. Okay, and that also powers the vacuum catalog feature on Dremio Cloud. Now, this has been an exciting year, 2024, because we saw the introduction of another really cool catalog project. Okay, so basically mid-year, you saw Snowflake announce this project called Polaris. And then Snowflake basically teamed up with many of the industry's biggest lakehouse players, including us at Dremio, AWS, Microsoft, Google, to contribute this project, Polaris, to the Apache Software Foundation, which is why it's currently in incubating status. Okay, so it's an incubating project. So now it's Apache Polaris. It's a community-run project. So again, right now on the PMC, or the PPMC, is the proposed PMC, you have, again, people from Snowflake, from Dremio, from AWS, from Microsoft, from Google, all helping shape how this project evolves. Okay, and basically some of the key features of Apache Polaris is addressing some of the key problems that people have when they first implement a data lakehouse, which is governance. Because what happens right now, a lot of the time, governance, if you deploy most open source catalogs, is basically done at your engine level. So you might create some governing rules in Dremio, you might have to create some governing rules in Snowflake, governing rules in this engine and that engine, and then you end up having to recreate that governance across every tool you query your tables with. And that can be really cumbersome. But the one thing that you bring to every tool is the catalog. So it makes sense that the catalog becomes the center of governance, because that is the thing that will communicate with every tool that tries to access your tables. So you end up with something like this. So here's like a picture of sort of like what Apache Polaris does. You have query engines that can talk to Iceberg catalogs, because again, Apache Polaris is implementing the Iceberg REST specification, which means any tool that already can talk to Iceberg REST catalogs can talk to Apache Polaris. So those tools can talk to Polaris, okay, which has role-based access controls built into it. So you have the ability to govern your tables. Right now, you can really govern your catalogs is the main unit, and I think that they might be just adding the ability to govern namespaces and tables. And we'll get into all that in a moment. But then that helps control access to Iceberg. And again, because it's based on the Iceberg REST catalog specification, it basically takes advantage of an aspect of the REST catalog specification called vendor credential vending. Because if you ever use a catalog before the Iceberg REST catalog, you might have noticed that like when you're typing in your Spark script, configuring the catalog can be a little painful, because you have to put in the right catalog credentials, you have to put in the right storage credentials for you to be able to access the data, successfully. If not, you're going to get errors. And then if you're using managed tools, you have to make sure they support your storage layer, and they have to have both, catalog and storage credentials. But with Iceberg REST catalogs, there's a feature called credential vending, where the catalog can then provide the storage credentials upon authentication, and they can, provide a temporary version of those credentials that only works for that transaction. So that way you're extra secure. Like, if those credentials get exposed, they're not going to be able to be reused. They're like a one-time use only thing, and the end user who's actually accessing the tables isn't aware of the credentials because the catalog's providing them. So all that discussion of storage credentials is really between the catalog and the engine, not the end user. The end user just has their catalog credentials. Cool. But when you think about the taxonomy of Apache Polaris, essentially the way it works is that it's you have a catalog, but the catalog is divided up into sort of sub-catalogs. So essentially your top level unit, your top level namespace are catalogs. And each catalog, they're referred to as internal catalogs because there's also a separate idea of external catalogs, which I'll get into later. But just like with any catalog you use in any database or data warehouse, the catalog can be then subdivided into namespaces. So think of them as like subfolders. Okay, so I can create namespaces under the catalog. So imagine that I have like, the marketing department catalog. That's a catalog. And then the catalog, we have maybe, a namespace for, social, another one for ad buys, another one for so forth. And then under the ad buys namespace, there's a table of like Google ad specific ad buys, another table for Reddit ad buys, and so forth. And you can see how this all breaks down and allows you to kind of really organize it. But the beauty of the catalogs is that now you can create the taxonomy you need and semantics you need to collaborate, because I can create, again, like let's say you're doing data mesh, I can create like a marketing catalog, and then that can have separate governance versus the accounting catalog, the finance department's catalog, etc. You can, or however you decide to split up your domains for that data mesh approach, I can create sort of that the separation of groupings of data sets as I like, whatever seems best. Okay, and those catalogs right now, you have role-based access controls at the catalog level. So I can control who has access to which catalog and what kind of access they have to that catalog. So just to kind of run through an example of how this would look like, okay, you have what's called a principal. So think of principals as users. Okay, they're people who are going to access the data. So each user will get a principal account. So that's one thing you would create in Polaris. Okay, so I would create a principal for each person who's going to access the catalog, or each group of people that's going to access the catalogs. I'm going to have the catalogs that I create. So in this case, we have a sales, a customers, and logistics catalog. Now what's going to happen is that I want to define how different ways you can use each of these catalogs. So these are referred to as catalog role. Well, first let's do principal roles. Okay, so first I want to take each user, each principal, and put them into different buckets. Okay, so in this case, I may create a role like of analyst, engineer, shipping partner, representing people who are from a shipping company that we work with who needs access to some of our logistics data. So I create these principal roles, but these principal roles don't determine, by having analyst by itself doesn't necessarily mean that you have access to anything. Each principal role can be assigned one or more catalog roles. Okay, so I assign the principals the principal role, and then I can create catalog roles. Okay, so in this case, I created 2 catalog roles for the sales catalog, a sales reader that just has a reading ability. So if you have a role that only has sales reader, that gives you the ability to read tables in the sales catalog. Let's say I create a role called sales writer. Okay, this has all the permissions for me to write and read to the sales catalog, or just to write. In this case, I might give both. And I do the same thing for the other 2 catalogs. And again, do you have to build it this way? No, you'll see that this is very flexible, that you can create catalog roles that have very, very granular sets of permissions to create sort of the primitives you need that are work. And then once you set up these primitives, it becomes really easy to set up the right permissions for principals going forward. Okay, but once I set up all my catalog roles, I can then assign the right catalog roles to the right principal roles. So for example, the analysts, they just need to be able to read the tables. They're going to go run queries and run analytics. So I'm going to give them access to the analyst role is going to have the reader role for each of the different catalogs. Okay. Now the engineer, well, they're going to need to read and write everything because they're ingesting the data, they're fixing the data, they're handling different types of tickets that are coming in for different data requests. So they need read and write ability for all of the tables, all of the catalogs. So I'm going to assign the engineer role to have all the different catalog roles in this case. Now the shipping partner really only needs the ability to read the logistics table or the logistics catalog. Okay, so in that case, I'm just going to give them a log, well, should be a log reader. I'll give log reader to the shipping partner, and that way they can read the logistics table or catalog and the tables that are within it. Okay, and this basically is the framework for which, so it allows you to kind of design your own framework. It gives you enough flexibility because again, these catalog roles can be anything. Because what you do is you create a role and then you can assign it all these unique granular permissions, which we'll see in the next few slides. So for example, you can assign a catalog role different table level permissions. So these basically say, hey, whoever has this catalog role can do these specific things to a table. Whether it is, are they allowed to create a table? Are they allowed to drop a table? Are they allowed to get a list of all the tables? So you can specifically say, hey, this role should have these specific functionalities allowed to them. You can do the same thing with views because Iceberg has a specification for views. So you can actually create views and store views within a Iceberg catalog. So there are primitives for determining what is the functionality for a view for the user. Then there is a namespace privilege for creating namespaces. Okay, so in this case, you can determine, hey, what are the features that a namespace can have? And then there's specific catalog privileges as well at the catalog level. And if you just want to give people complete access, okay, you can do something like catalog manage access and catalog manage content, and that would pretty much give them like complete access to the catalog. So you can determine and really sort of curate what each specific role can and can't do at a very granular level by assigning all these different privileges to each of those catalog roles. Again, create the framework of role types that you need, and then going forward, all you have to do is just keep assigning the right catalog roles to the principal roles, and then assigning the right principal roles to principals, so they have the access that they need. Okay, so at the end of the day, you have several different Iceberg tables, and those Iceberg tables need to be put into a catalog. Now, they could be put into a internal catalog. Okay, so again, these are the catalogs we've been talking about that are managed by Polaris internally. But another really cool feature of Polaris is that this feature called external catalogs. So what if you really liked some of the stuff I talked about with Nessie earlier, and you want to take it and you want to use Nessie for ingesting your data and take advantage of branching and that validation and create your CI/CD pipelines? You can do so and then still expose those tables through Polaris. So that way Polaris can still act as your governance layer and and then maybe move some tables over to some internal catalogs. Like you have some flexibility here. Okay, so I can connect these external catalogs as long as they support the Iceberg REST specification to Polaris. So that way, basically from my end user's point of view, they just connect to one catalog and they can see all the tables that they should have access to in one place. Now, then basically I have my internal external catalogs, and all that becomes visible through Apache Polaris, which allows me to govern those catalogs and allows me to federate those catalogs, again, connect multiple catalogs to Polaris. Okay, giving me a really robust lakehouse exposure. Now, at the end of the day, fundamentally though, that's not enough federation because you're also still going to have a long tail of data, whether it's your own data or data you purchase from third-party marketplaces like the Snowflake marketplace or the AWS marketplace that might be inside of databases, data lakes, and data warehouses. So this is going to end up being why you're going to want a data lakehouse platform that can connect all these data sources. So that way you can truly, really unify all your data. Okay, this allows you to have another layer of governance through a governed semantic layer in the Dremio platform, and the ability to federate queries among all the tables you have access to through Polaris, along with your databases, data lakes, and data warehouses. Okay, giving you sort of a real full, robust lakehouse picture, which you can then deliver that data, using the REST API in Dremio or JDBC ODBC interface, or using Apache Airflight to your different use cases like AI workloads or BI workloads or whatnot. So you end up getting this sort of like really robust data lakehouse picture, just to kind of see how we take the catalogs that we've talked about in this episode and kind of build out a full data lakehouse architecture and see what that final result looks like. So hopefully you guys enjoyed this. Now, if you guys want to just really kind of get hands-on with this and kind of see this in action, my recommendation is to do one of these tutorials. Okay, the easiest one's going to be the one all the way to the left. The other three have basically are end-to-end. So you go from ingesting data to building out a BI dashboard all in one tutorial. But basically all of these involve you building a lakehouse on your laptop. So it doesn't require you to have to create an account anywhere or to deploy any cloud infrastructure. All of this can be done on your laptop. So you can see a full-on lakehouse in production on your laptop to get an idea of sort of how this type of environment looks like and it works, and understand the feel of the lakehouse and why lakehouse catalogs are so important. and sort of get to see some of these features that we've talked about in this video. Now, again, there will be another episode, December 10th, where I'm going to be talking about other catalogs. So I'll be covering like AWS Glue, Unity, Graphatino, Lakekeeper, all the other catalogs there. So that way you can learn more about the catalog ecosystem. But hopefully this has been helping you understand sort of like the world of catalogs, sort of what they can offer your data lakehouse architecture. And with that, if you have any questions, put them in the Q&A box. I will go take a look at the Q&A box to see if there's any questions now. Okay, so I see Q&A. Oh, bring that one over here. Okay, so hello, great content. What is your opinion about Unity Catalog? It's just at the beginning. Can it evolve? Thanks. Unity Catalog's fine. I am going to cover it more deeply in the next episode. But again, what catalog you want to use should be based on sort of like what are you trying to do. So Unity Catalog generally is going to make the most sense if you're already a big user of Databricks. So you already have lots of Delta Lake tables. Okay, because that's the Unity catalog. Unity Catalog is very built for particularly cataloging not Iceberg tables, but Delta Lake tables. To the extent that there's Iceberg functionality in Unity is usually through the uniform feature. And what the uniform feature does is that it takes, like, you write to your Delta Lake table. So your tables are still written to as Delta Lake, but then the catalog will asynchronously write Iceberg metadata. So you'll have a copy of the metadata in Iceberg format co-located with your Delta Iceberg Delta metadata. And that then gets exposed via the REST catalog specification. So I can connect with tools like Dremio, which just introduced its Unity connector, or through as an external catalog in Polaris. I can connect to that Unity catalog, and those tables will become readable via that catalog, via that connection as Iceberg tables. Okay, with Dremio, that's really nice because Dremio has a lot of optimizations with how it leverages the Iceberg metadata to give you sort of really top-notch performance. So it allows us to exercise that. There is some caveats though, because it's asynchronous. So there is some level, like if you're making very frequent changes to a Delta Lake table, there is some batching that happens. So in that case, if you just created 10 new Delta Lake snapshots, you might end up only creating one new Iceberg snapshot, and it'll batch those changes. So you don't get the same granularity time travel wise. Two, certain features, if you're using them, will either preclude you from using uniform, or using uniform will preclude you from other features, particularly like liquid clustering, which makes sense because there's just a lot of writing going on at the same time. It would be really hard to kind of keep that consistent. And you cannot write to the Iceberg table. So it's not a full-on Iceberg experience where you can take advantage of the right side features like partition evolution, but again, the reason you'd probably be using Unity is because you're mainly working in Delta Lake. So in that case, a lot of those trade-offs are, not really trade-offs because they're not part of what you're trying to do. But if you are trying to build like an Iceberg data lakehouse where you're writing to Iceberg and taking advantage of things like partition evolution and hidden partitioning and a lot of the other niceties of Iceberg, then you're probably going to be better off using something like a Polaris or a Nessie. But again, it depends sort of like where's the gravity of your work, whatnot. But regardless, either way, you can federate all these catalogs and connect to tools like Dremio, or be federated using Polaris, so that way you can create sort of a central access point. Now, how this will evolve, my prediction is that you're going to start seeing the next layer of sort of evolutions of a lot of these catalogs with the V2 of the REST spec, because particularly, actually, I just wrote a blog on Medium about this, like 10 things to look forward to in Iceberg in 2025. So I would recommend looking me up on Medium and reading that article. It's actually on the Dremio Medium blog, so it should be pretty easy to find. But there's going to be something in there called the scan planning endpoint that should change how a lot of catalogs enable reading of tables. That could at least facilitate more reading, multi-table format reading. In the future, there could be a similar endpoint being created that would enable the right side of that equation, but that's a little bit trickier, just because of the way you write the data, and the engine's usually writing the data. So the engine would have to have some sort of understanding of like the format. So it's going to be a little bit harder to abstract away that piece. But on the read side, I would imagine that the scan planning endpoint could be a vector for creating sort of universal read access via the catalog, where you don't even need to translate metadata anymore using uniform or the Xtable, because a catalog will become the layer for understanding that and doing the scan planning. There's other really cool stuff about that, but again, this is all stuff that's sort of like really far looking. But that I would recommend reading that article. Talks about the potential of a lot of the things that are coming to the Iceberg spec and the Polaris spec and other things over the next year. So again, if you have any other questions, put them in the question Q&A box. And otherwise, I will see you all on December 10th, where I'll be talking about all these other catalogs. And again, make sure you tell your friends to go sign up for this course, so that way they can watch the previous these two episodes that we've done so far on demand and get caught up as we reach our fun conclusion on December 10th. So thank you all very much. I'll see you all next time. Have a great one.